Welcome to the Explainer. Today, we're jumping right into the magic behind AI image generation. You know, the tech that turns a few simple words into these absolutely stunning, complex worlds.
I mean, how can a computer, just pure logic, create art? It feels impossible, right? But the answer? Well, it isn't about the computer understanding things the way we do. It's all about a surprisingly elegant process of creating something amazing from pure chaos.
And this is it. This is the whole key. It all starts with this one simple but super powerful idea: learning how to methodically reverse noise. Seriously, everything we're about to talk about, it all builds on top of this one concept. So, let's pull back the curtain on the fundamental mechanism that powers these incredible tools. You'll see it's less about an AI painting something and a whole lot more about it, well, revealing something that was hidden.
Okay, so the official term here is a diffusion model. And what that really means is that the AI isn't starting with a nice, clean, blank canvas. No way. It's actually starting with a screen full of complete random static. You know, like an old TV that's lost its signal. And its one special skill is that it has learned how to perfectly, meticulously remove all that static to reveal a hidden image from within.
So how does it learn to do that? It's this pretty wild two-step recipe. First, the forward process. We take a real image, any image, and we just add a little bit of noise to it, over and over, until it's nothing but pure static. It's gone. Then comes the reverse process. This is where the AI comes in. We train it to look at that noisy mess and predict exactly what noise was added so it can subtract it. It learns to do this step by step to rebuild the original image. It's kind of nuts when you think about it. The AI learns how to create by first mastering how to destroy.
And this is honestly the best way to think about it. Imagine a sculptor who starts with just a messy, lumpy block of stone. That's our noise. And they just chisel away in tiny, tiny little passes until a beautiful statue appears. That's exactly what the AI is doing. Each step is a tiny, super careful tap of the chisel, slowly turning that chaos into form.
Okay, so that's the core idea. But it had a huge problem, a really big one. It was incredibly, painfully slow and took a ridiculous amount of computer power. So that's where our next big breakthrough comes into play. See, working directly on all the pixels in an image, we're talking hundreds of thousands of them, is accurate for sure. But it's just so slow and resource heavy. So the big question for the engineers was, how do we take this amazing but totally impractical technology out of the research labs and get it onto a computer that you or I actually own?
And the solution they came up with was just brilliant, a genius workaround. Instead of making the AI work on the massive pixel-by-pixel image, they have it work in something called latent space. You can think of it as a highly compressed, kind of abstract version of the image. It's like the difference between sculpting a giant block of marble versus working on a tiny but super detailed clay model of it. You get the same result, but it's way, way faster. And just look at that number, 48 times smaller. The data it's working with is just a fraction of the original size. This single innovation, this one idea of using a smaller data footprint, is the reason tools like Stable Diffusion became such a revolution. It's what made it possible to put this immense power under regular consumer-grade hardware, onto our home computers.
Okay, so this whole system basically works like a three-part assembly line. First up, you've got the text encoder. Think of it as the universal translator. It takes your words and turns them into a numerical language the AI can actually understand. Next, you have the image generator. This is the artist. This is the part that does all that clever denoising work in that super efficient latent space we just talked about. And finally, you've got the image decoder. This is the builder. It takes the finished blueprint from the artist and constructs the final, full-size, beautiful picture that we get to see.
All right, so now we know the how behind this incredible engine. But how do we, the users, actually get to, drive the thing? How do we steer it to create what's in our heads?
Well, that denoising process, that sculpting, it's not random at all. Your text prompt, the words you type in, acts as the guide, the steering wheel for that virtual sculptor at every single step of the way. This is where your creativity plugs directly into the AI's process.
So let's walk through it. Say you write a red bicycle on a beach at sunset. First, the text encoder turns those words into numbers. Then, those numbers are fed to the denoiser to influence every single step of the creation. So as the image is slowly appearing out of that static, the AI is constantly checking back with your instructions. It's asking itself, okay, does this look a little more like a red bicycle now? How about a beach at sunset? It's a guided journey, all the way from noise to your specific vision.
Now, this core technology of denoising, it's so powerful that it has unlocked a whole bunch of other amazing tools that go way beyond just making a picture from scratch.
First up, in-painting. You can think of this like a magic eraser or a smart patchwork tool. You can literally draw a mask over a part of an image you don't like, and the AI will intelligently fill in that hole with something that looks like it was always meant to be there. It's perfect for removing unwanted objects or people from a photo.
Then there's upscaling, or super resolution, and this is so cool. It's not just making an image bigger, stretching the pixels out. No, the AI is actually hallucinating the missing details. It looks at the blurry low-res image and intelligently adds in the detail and texture it thinks should be there, giving you a genuinely sharper, higher quality picture. It's more like an artist restoring an old painting than just hitting zoom.
And this is where it gets really personal. Fine-tuning. Using a technique called LoRA, you can actually teach the AI a new style or a new object or even a specific character. And the crazy part is you only need like 10 to 50 images to do it. This is how people teach the AI their own unique art style or how to draw their own original character over and over again.
So, let's zoom out a bit. Let's bring all these pieces together and look at the bigger picture of what this technology really means. Okay, so if you're going to remember anything from this, remember these 4 points. First, diffusion AI works by learning that really elegant process of reversing noise. Second, the big breakthrough of latent space is what made it efficient enough for all of us to use. Third, our text prompts give us precise creative control over this whole process. And finally, all of this has unlocked an entire ecosystem of seriously powerful creative tools.
And this quote really nails it. Stable Diffusion represents a democratization of AI art generation. What that means is this isn't just some technical thing happening in a lab somewhere. It's a fundamental shift in who gets to be creative. These tools that used to need supercomputers can now run on a regular gaming PC, opening the door for millions of new artists and creators around the world. Which leaves us with this pretty mind-bending question, right? If an AI can learn to create such incredible things from pure chaos, what are the limits of digital creation anymore? It really pushes us to rethink not just how art is made, but what art can even be. As this journey from noise to new worlds keeps getting wilder, maybe the only limit left is our own imagination. Thanks so much for joining us.